Okay, now let's get started with the first question. Okay, now let's say here question number 12. There are X boys and Y girls in the class A. Okay, and then the girls outnumber the boys by 4. Okay, so let's start with that. So now we're gonna say, let's assume this is class A. Let's say this is class A. And this, okay, let's start with the class A. So let's say X boys, Y girls. But let's say the girls outnumber the boys by 4. What that means the boys are more than the girls. The girls outnumber the boys by 4. Means the girls which are Y are bigger than boys. So I can say Y girls minus boy, it must be equal to 4. Means when you find that difference, it's going to be 4. And we know girls are bigger than, having more number than boys. So they outnumber boys by 4. So that's it for class A. Now if you go to class B, they say now they join up with another class B. Oh, so there's another class, which is class B, whereby there are twice as many boys as girls. So now you know what I'm going to do? Me personal face. I'm not going to write anything here. Let me jump to the next one, and I'll go back a little bit. That's a tricky with this question. Sometimes, you know, the more question you do, the more you get used to it. So let's say here, class B. So let's say this class B. Class B. So the class B, they say it has 3 more boys. What about boys are X? So X plus 3. And so boys, for them to be equal, 5 less girls. Girls are Y, but are there 5 less. You see? Than in the class A. Okay. So girls are 5 less, but boys are 3 more. But now look, I'm gonna come back in this sentence now. Let's say there are twice as many boys as girls. So whenever they say as many boys twice, or even if they say thrice or twice as many boys as girls, take the last name is when you multiply by this twice. You see? So twice as many boys as girls. Oh, so the twice as, look at the last name, is for girls. Twice as many boys as girls. So the twice is going to be for girls. Girls is for Y. So see, I'm going to put my twice here. So what I'm going to do then, just simplify. Simplify these two. That's all you're going to have. So now, this is going to be X plus 3. And this is going to be 2Y. And this is going to be negative 10. So let's rearrange. Okay, so I'll take X over and this negative 10 back. So this is 3 positive, and if this negative 10 comes over, it's going to be 3 plus 10. It's going to be 13, and here we have 2Y, and this one go over minus X. So this is going to be one equation, and this another equation. So I can put them together. I can say Y minus X. So my equation, because they say which system of the equation can be used to solve for X and Y. So the system of equation is going to use to solve X and Y is Y minus X equal to 4. And then 2Y minus X equal to 13. And if you look careful, all of this, Y minus X equal to 4, and it is on here. So option 3. So now we want to go for question number 13. Question number 13. Let me see if it's recording sometime. Okay, I had a problem. This past week I was solving about for 2 hours, and then I realized it was not recording. That's why I want to make sure all the time. Okay, so let's just erase this. Okay, this is way easy. This is way easy. Okay. Okay, law of exponential. Let's start with this one here. So let's say here 3 times 2 negative 1 over 3. So we do not have a type of rule. Like for example, if somebody give me A times B power X. If these bases are different, you cannot bind them together. Meaning, you cannot say this is going to be ABX. You cannot say ABX, no. Because the bases are different, okay? If it was, let's say 2 times 4x, this one I could, because I was going to simplify this. This is going to be 2. 4 means 2 power 2, but if there's an x, it's going to be 2 power 2x, and here this is 2. When there's no power means power 1. When there's no power means power 1. You understand? So because 4 means it's 2 square, so 2 times x is 2x. That's what that is. So now when the base are the same, and if there's a multiplication, then you're gonna say only write one base. If you have that such condition, you write only one base, and then you add this power. You say 1 plus 2x. Why do you add? Because there's multiplication and the base are the same. This is why I had to split these to have the same base. So now for this one here, shows me sorry. So for this one here, we say 3 times 2 negative 1 over 3. So the base are different. So if the base are different, there is no such exponential rule where you can put them together, say, oh, 3 times 2 equal to 6. No, there's no such a thing. So this is going to remind the way how it is. 3, or if you want to simplify, I can take this to the bottom. Because you know why? I can reciprocate, because this has a negative power. So if it has a negative power, you can turn it to positive. But if you want to turn to positive, if it's at the top, it's going to go to the bottom. It's going to become 1 over 3. It's acceptable to do that. You see, only if it's negative, you can take to the bottom. Oh, yeah, stuff like that. So now this time I say 3, but when you say 2, 1 over 2, this time I say, if you don't want to write it as a power, you can write it as a 2 square root of that. If you have, let's say, a 1 over 4, this time I say a power 4. You see what I'm saying? So now this is 2, 1 over 3, this time I say 2, and I can put 3 here. So if I had to simplify this should be my final answer. Or that, but this is final. So this is not true. Because what they did, like they put them together. We don't have this rule. Let's go number 2. Number 2. Number 2. Number 2, you have negative 27, and you have 3 here, and you have a half, and you have a 1 over 2. No. Now let's go. So which number, when you cube root negative 27, you get negative 3? Because you know why? If you take negative 3 times negative 3 times negative 3, you get negative 27. So in other way, if I cube root, because there are 3, if you cube root this, it's going to give you negative 3. Now let's go to the bottom. To the bottom, now we go 1 power half, or you can just say square root, just like how I say, when you have anything power 1 over whichever number. So you're going to put this inside. So now this is like a square root because of these 2. You see what I'm saying? So now this same is say negative 3, but you can separate this same square root of 1 and square root of 2 separately. Okay? Now we have this here. So negative 3, and then this, when you square root 1, you get 1, and this can be square root of 2. See what I'm saying? Now this is going to go to the top. Take this to the top. So it's going to be negative 3 times square root of 2 over 1. So finally, it's going to be negative 3, 2 over 1. But anything divided by 1, it does something. It's like somebody say a over 1 equal to a, x over 1 equal to x. So anything divided by 1 is going to remind you how it is. Negative 3, square root of 2, this is going to be final answer. And if you look careful, we took left hand side, we simplified, we go the same as the right hand side. Negative 3, square root of 2. So yes, this is true. Now we come for this one. So for this one here, now 3 over 4. Okay, let me simplify. But you can separate this. This is saying square root of 64, and they can say square root of 27 is acceptable. We had that rule. It's very acceptable. Now you say this same is saying, so I'll take this left hand side. 3 over 4. When you square root 64, you get 8. So here you're going to get 8. But here, there is no number when you square root 27, you get like actual number. No. So we're going to leave the way how it is. But I can simplify. Look, 27 is like 9 times 3. But then I can separate this. I can say square root of 9, and then I can say square root of 3 is acceptable. So when you square root 9, you get 3, and then we still have square root of 3. So instead of writing 27, I can write here 3, square root of 3. But I can simplify here. Look, by 4 itself 1, how many 4 in 8? 2. By 3 itself 1, by 3 itself 1. So 1 times 2 equal to 2, and 1 times square root of 3, square root of 3. You see what I'm saying? Square root of 3, right? And if you want to simplify, you can simplify further. You can rationalize the denominator. So rationalize the denominator means whenever you have a root, it's not a good way, even though it's acceptable like that, but I can simplify further by multiplying by the same thing. You see this at the denominator? Up and down. Take this, multiply up and down. Up and down. But what you do, this is remember it's positive. It's going to become negative and negative. Same thing, but you change the sign. Up and down. So remember, top and bottom. So negative and negative gives positive. So it's going to become positive. So this, let me say 2 square root of 3 plus square root of 3 times square root of 3 equal to 3. How? Look, I can put in a single square root. 3 times 3 equal to 9. But when you square root 9, you get what? 3. So it's let me say 3. So what you need to know, if somebody gives you square root of x times square root of x means equal to x. You don't even have to bother. As long as the root here are the same. Not if it's, let's say here 3. Then it's not going to be x. This is going to be another. You cannot do anything. You leave the how it is. Only, but if you do 3 and 3 same, and then I could have say x times x. And then I can put here what? Cube. And this is x squared cube. You see, that's why I say this is going to give us 3. So this one here, we know for fx, this is not equal to 4 over 3. So for that case, only, okay, just look. If these two are not equal, so even if these two are equal, it doesn't matter. It means everything is wrong. Because all of them have to be equal to each other. But I will know for effects, these and these are equal because when you square this, you get 4. And when you square 9, you get 3. So these are equal, but the problem, these are not equal to this. So since this one are disqualified, so everything is going to be wrong. So only B is going to be right answer. Look here. You FaceTime, play. Come here, subscribe, share this video to a lot of people, like, and if you leave a comment, I'll make sure I respond to your comments, and feel free leave a comment. And thanks a lot. You know, if you FaceTime, donate to my channel. 1 ring, $1, 2 pounds, £100, $50, £50. Even if you want to do £1 million, appreciate Tom will say no. You know, that's gonna be a surprise. So thanks a lot, man. It can be 50 cent pounds, 50 cent dollar, you know, riyal, any money, shillings, rand. I appreciate, man. Thanks for your time, and I appreciate. Peace. Peace.